Exercise 1.4126 is in previous video. We'll solve from 7. Now 7, A, B, C, D are given. A is the set of natural number. A actually, this is equal to 1, 2, 3, 4 and dot dot. Next, B is equal to is even natural number. So 2, 4, 6, 8, 10 like this. C is X is an odd natural number. So C is equal to 1, 3, 5, 7, 9 and so on. Now D is equal to X is a prime number. So 2, 3, 5, 7, 11, 13 and so on. What we have to do? We have to find A intersection B. First one, A intersection B. Roman 1 A intersection B. Let's check that. A is the set of all natural number. B is equal to the set of even natural number. So A intersection B, check 2 is common element we have to write. So 2, 4, 2, 4, but in case of natural number 6, 8, all the natural numbers are there. A intersection B will be the set of all even natural number 2, 4, 6, 8, 10 and so on, all even natural number. That is actually the set B. See that here B is subset, the even number set is subset of A, because all the even natural number is in the set A, all the even natural number is in the set A and B is the set of only even natural number. So B is subset of A. That's why A intersection B, we are getting the subset. Number 2, A intersection C. Similarly, A intersection C will get all the odd natural number 1, 3, 5, 7, 9 and so on. And that is actually C, because this C set is also subset of A. Next, number 3, B intersection C. B intersection C. Check that there is no common element. This is even, this is odd. So you cannot find any element in B intersection C, so that both belongs to B intersection. Oh, this is 4. This is question number 4. Now 3 is A intersection D. 3 is equal to A intersection D. A is natural number and D is prime number. So only prime number will be there, because all prime numbers are natural. So this is 2, 3, 5, 7, 11. All prime number I am writing. So this will be equal to the set D itself. 4 is this one. Number 5, B intersection D. Number 5, B intersection D. B intersection D. B is set of all even natural number. B is set of all even natural number and D is prime number. So in this set only even prime will be there, and that is only one element we can find, 2, which is both even and prime also. Number 6, C intersection D. C intersection D. So in C, the odd natural numbers are there, and in D all prime numbers are there. So other than 2 there exists no even prime number. So and the remaining all prime numbers are odd. So what we have to write? We have to exclude this 2 only. So from the set D, if we write 3, 5, 7, 11, 13, this will be also the set of prime number minus 2. Actually 2 will be not there. Set of prime number greater than 2. This is the set of prime numbers greater than 2. Okay, this is number 6. Now number 8 we will solve. Number 8, we have to check whether the pairs of set are disjoint or not. Now remember one thing, disjoint set, two sets A and B are said to be disjoint when the condition is A intersection B is equal to phi. A intersection B, there is no element in A intersection B. Now 8 Roman 1. Check two sets given, first set 1, 2, 3, 4, and x is natural number such that 4 less than equal to x less than 6. So first set is 1, 2, 3, 4, and next set intersection, that is actually 4, 5 and 6. Natural number which satisfies that condition is 4, 5, 6. Now one common element is there, this 4. So that is equal to 4. So in this case, the sets are not disjoint, as their intersection is not equal to phi. This is not equal to phi. One element is there. Number 2, A, E, I, O, U and C, D, E, F. Their intersection is also, if you assume this one is A and this one is B, intersection of A, E, I, O, U, this intersection, the second set C, D, E, F, that is equal to the element E, which is not equal to phi, and which imply they are not disjoint. If it is equal to phi, then they will be disjoint. Now number 3, x is an even integer and x is an odd integer. This one, the set intersection of this set x such that x is an even integer, this set, and intersection this set x such that x is an odd integer, this is equal to phi. This implies they are disjoint. We can say that they are disjoint. Now number 9, before finding their difference, this A minus B implies difference of the set. Let us discuss about their definition of difference of any two sets. definition of difference of two set A and B, written as A minus B. It is actually the set of all elements which are in A but not in B. X belongs to A but not X belongs to B. X belongs to A, X does not belongs to B. This is the definition of difference of set. Now 9 A, B, C, D given, we have to find their difference. A is the multiple of 3 from starting from 3 to 21. This is the multiple of B, the multiple of 4 starting 4 to 21. This is the multiple of 2, 2 to 16. This is C, this is D given. Now A minus B, for first example I am writing the set A minus B. A is 3, 6, 9, 12, 15, 18, 21. This is A, and B is equal to this minus the set B is 4, 8, 12, 16, 20. Now if there is any common element, that element we have to subtract from A. Those element A minus B is that collection such that that element will be in A in this set but not in this set. So A is in A but not in B. 6 is in A but not in B. 9 is in A but not in B. But 12, this element is in A and B. So you have to subtract that. You have to exclude that. Similarly 15, 18, 21, they are in A but not B. So that is A minus B. This is equal to 3, 6, 9, 15, 18, 21. This is A minus B. That implies if any common element is there, that element we have to subtract from the set A. Then we can find the difference. This is A minus B. Now number 2, A minus C. A minus C. This will be same thing. If any common element is in A and C, that we have to subtract from the set A. A and C, check any common element is there or not. See, 6 is there. In A and C, 6 common, 12 common. 6 and 12 common. All other elements are different. 3, 9, 15, 18 and 21. So A minus C, the collection will be 3, 9, then 15, 3, 9, 15, 18, 21. This is A minus C. Number 3, A minus D. A minus D. So common element of A and D we have to omit from A. A minus D. Mark the common element first. D 5, 10, 15 and 20. Only one common element. Only one common multiple is that. This is multiple of 5. This is multiple of 3. So 15. So we have to omit this element from A. Then you will get A minus D. So what will be A minus D? That is equal to only 15 if we subtract from A. 3, 6, 9, 12. Omit 15, then 18 and 21. This is A minus D. Number 4, B minus A. Number 4, B minus A. So the definition will be the elements will be in B but not in A. So B minus A, the elements will be in B but not in A. That is the definition of B minus A. Now check that B is multiple of 4. So if any common element is there, that element we have to remove from the set B. So 12 is common element in A and B, only 12. So we have to remove it from B. So then the element will be 4, B minus A will be 4, 8, 16 and 20. This is B minus A. Number 5, C minus A. Same thing. If any common element are in C and A, we have to remove that from C. As we are subtracting A from C, so we have to remove from C. So C minus A, check that C is multiple of 2, A is multiple of 3. 15 is there, 12 is there and 6 is there. 6 and 12. These two you have to omit from C, then we will get the answer. So C minus A will be 2, 4, 8, 10, 2, 4, 8, 10, then 14 and 16. That means the multiple of 3 we have to subtract from C. We have to omit from C. Number 6, it is D minus A. D minus A, same procedure. 5, 10, 15, 20. In A, any common element. This is the only common element, 15. So D minus A, the common element of D and A, we have to remove from D. So 5, 10 and 20. This is D minus A. See that A minus D and D minus A are not same. Now number 7. Number 7, it is B minus C. B minus C. That implies common element of B and C will remove from B. Common element of B and C, 4 is there, 8 is there, 12 is there, 16 is there. 4, 8, 12 and 16. B and C common element. So this common element we have to remove from B. Then we will get B minus C. Then only 20, the singleton set. Number 8. B minus D. B minus D. So common element of B and D we have to remove from D. Sorry, remove from B, from which we are subtracting. Common element of B and D. Check, any common element is there, 20. 20 is the common element of B and D. So you have to remove this from B, you will get B minus D. That is 4, 8, 12 and 16. 4, 8, 12 and 16. That will be B minus D. 4, 8, 12 and 16. Number 9, it is C minus D. C minus D. Same thing, common element of CD remove from C. Common element of C and D remove from C. 10 is the only common element of C and D. So remove from C, then it will be 2, 4, 6, 8, 12, 14, 16. So the set will be 2, 4, 6, 8, 12, 14, 16. This is C minus D. Number 10, D minus B. D minus B. So for D minus B, what is common element of D and B and subtract from D. Common element of D and B, 20 and subtract from D, then it will be 5, 10 and 15. 5, 10 and 15. Each case you can check B minus D, D minus B are not same. Similarly, B minus C, C minus B, if you find, you will not get same result. Number 11, C minus D. That implies it will be C minus B. Already C minus D, so we will find C minus B here. C minus B, it is given. So C and D common element we have to find. C and D common element, this is 10. C and B common element we have to find. C and B common element 4, 8, 4, 8, 12, 16. 12, 16. These are the element. So it will be, the answer will be the remaining element of C, that is 2, 6, 10, 14. 2, 6, 10, 14. These 4 element in C minus B. Last one, number 12. That is D minus C. That implies common element of C and D removed from D. Common element of C and D removed from D. Common element of C, D only 10. Removed from D, you will get 5, 10. Sorry, 10 we have to remove. 5, 15 and 20. So this is the answer of 9. Next, last 3 problem, 10, 11, 12. Number 10, set X and Y given. We have to find X minus Y, Y minus X and X intersection Y. So Roman 1, X minus Y, that implies common element of A and B, subtract from, omit from X. X minus Y, X minus Y, that will be equal to this B and D common, we have to remove from X. B and D we have to remove from X. So that will be the set A and C, element with A and C. Y minus X, this will be opposite of that, the common element of X and Y you have to omit from Y. Then you will get F and G. Now X intersection Y, that is the common element of X and Y. So this is equal to B and D. Now check that we can write one definition of X minus Y. That is X minus Y is equal to X minus of X intersection Y. We can write that X minus Y is equal to X minus of X intersection Y. Similarly, X, Y minus X will be the reverse one. Next, number 11. It is given if R is the set of all real number, R is the set of all real number, and Q is the, this is real number set, and Q is the set of all rational number. So what will be the set R minus Q, that R minus Q. So R minus Q, this set, this one, in some books you can see that the difference is also written like that. R minus Q, that implies all rational number. All rational number we have to omit from, because all rational number are real. All rational number are real. So we have to omit each rational number from the set R. Then only irrational number will be there. So this will be set of all. What will be the result after subtraction? Set of all rational number. This will be set of all irrational number. Sorry, this will be set of all irrational number. Next, 12. Statement whether following true or false. Check that they are disjoint set. That implies there will be no common element, but we can see that there is one common element. This is 3. So the statement is false. So your answer will be as the intersection is non-empty. Next, A, B, C, D, they are disjoint. Same problem. This A is there. So this is also false. Justification same. Intersection not 0. Sorry, not equal to 5. Now 2, 4, 10, 2, 6, 10, 14. So the check no common element. So this is true. No common element. So this is true as intersection is 5. Justification intersection 5. Similarly for next one also true and justification as intersection is 5. Okay, you can see the previous exercise. I have given the link in description.